You know, the internet feels like it's just always been a part of our lives. But what if I told you it was born from Cold War paranoia and a frantic race to survive a nuclear attack? Welcome to The Explainer, where today we're digging into that completely unexpected history.
So, let's start with the big question. Who actually invented this thing? Well, it wasn't one single person having a eureka moment. The real story is, honestly, way more interesting and collaborative.
Yeah, there was no lone genius. It was more like a high-stakes quest with a bunch of different heroes, all sparked by something you'd probably never guess: the Cold War.
That global tension, that constant threat, actually lit the fuse for a technological revolution that nobody saw coming. It all kicks off in 1957. The Soviet Union launches Sputnik, and that beep, beep, beep from orbit sends a total shockwave across the United States. President Eisenhower knew America had to catch up, and fast, so he created ARPA, an agency designed to fund high-risk, high-reward research, and that's the seed that would eventually grow into the internet.
Okay, so ARPA had the money, but it needed a mission, a vision. And that vision came from a computer scientist who had an idea that sounded like pure science fiction at the time. His name was J.C.R. Licklider. And way back in 1962, he imagined this wild concept: an intergalactic computer network. A world where anyone could access data from anywhere. I mean, it sounded crazy back then, but that became the North Star, the ambitious goal for everything that came next.
But a big vision is one thing. You need a solid technical foundation to build it on. And to do that, engineers had to solve three really fundamental problems.
The first problem was born from pure Cold War paranoia. Over at the RAND Corporation, a guy named Baran was given a terrifying task: figure out how the U.S. could still communicate after a nuclear attack wiped out its central command posts.
Baran's solution was absolutely brilliant. Build a network that looks like a web with no single point of failure. It was a distributed network, so if one part gets blown up, a message could just find another route, kind of like water flowing around a rock. He ran the simulations, and they proved it would work. Even if half the network was destroyed, the message would still get through.
Okay, so at the same time, all the way over in the UK, another computer scientist named Davies was tackling a totally different problem: efficiency. He saw that sending one huge chunk of data was like having a single slow truck clog up the entire highway.
And his solution was a game changer. He called it packet switching. The idea was to chop up big messages into tiny little packets. Each packet could zip through the network on its own, like a fleet of motorcycle couriers, and then they'd all get reassembled at the destination. This made everything unbelievably more efficient.
All right, so now we have a network that's tough to kill and super efficient, but there's still one massive problem. The different computers hooked up to it couldn't actually understand each other. They were all speaking different languages. They needed a common set of rules. And that first common language came from Leonard Kleinrock's team at UCLA. They developed something called the Network Control Protocol, or NCP. You can think of it as the first official rulebook for ARPA's brand new network, the ARPANET.
So with all the key ideas finally in place, it was time to flip the switch. In 1969, the team gathered around for the very first test of the ARPANET. This was the moment of truth.
So a programmer at UCLA starts typing LOGIN to connect to a computer hundreds of miles away at Stanford. He types L, and Stanford gets it. He types O, they get that too. Then he types G, and the whole system crashes. The first message ever sent across this new network was, fittingly, just LO.
So the ARPANET worked? Kinda. But it was like a walled garden. Its protocol, NCP, was slow, and crucially, it couldn't connect to other networks. For this thing to really take off, it needed a truly universal language.
And this is where two of our main heroes come back into the picture. Kahn and Vint Cerf. They saw something bigger. Not just connecting computers, but connecting entire networks. They set out to build a universal translator for the digital world. And the leap they made was just massive. The old protocol, NCP, was like a local dialect that only worked in one town.
Their new invention, TCP/IP, was a universal language. It was specifically built to handle errors and basically guarantee that a message would get there no matter how messy the connection was.
They published their design in 1974, and it cleverly split the work into two parts. The IP, or Internet Protocol, is like the Postal Service. It addresses and routes each packet. Then TCP, the Transmission Control Protocol, works at the other end, making sure all the packets arrive safely and putting them back together in the right order. That two-part engine is still what powers our Internet today.
And as Vint Cerf himself explained, their goal wasn't just technical, it was philosophical. Back then, computers existed in these closed-off silos, and IBM could only talk to another IBM. Cerf and Kahn wanted to create a totally open system, to break down those walls for good.
So now, with this new universal language, a small government experiment was about to go from a handful of labs to, well, everywhere.
The adoption of TCP/IP just created this huge snowball effect. The military made it the official standard, which led to the big switch on January 1st, 1983. A lot of people consider that date the modern Internet's real birthday. And of course, that paved the way for the World Wide Web just a few years later.
And the pioneers who built all this? They've left behind an incredible legacy. Vint Cerf and Bob Kahn are rightly known as the fathers of the Internet. And alongside other key leaders like Larry Roberts and Bob Taylor, they literally architected the digital world that we all live in today.
And that's our explainer on the unexpected history of the Internet. A story that started with a military project to survive a catastrophe and somehow became a global platform for connection and knowledge. It kind of leaves you with a final thought, right? If survival and research drove this revolution, what great challenge is going to inspire the next one?